Hi, I'm Hadrian Da Vinci, and today I'm going to discuss how to set up your own large language model locally. Specifically, I'm going to discuss this in terms of why you'd want to run your own LLM locally. Then I'm going to discuss alternatives to running Llama.cpp. And then after that, we're going to download a model of choice from Hugging Face. Then we're going to set up our own Llama.cpp server in a Docker container. And then I'm going to show you guys how to access this with your browser, command line, and Python. And then we'll wrap it up by discussing some optimization tips. So let's start off by discussing why you'd want to run your own LLM locally. So first and foremost, I think privacy is a big reason why, right? When you're talking to your LLM, when you're conversing with it, when you're sharing data, you want to keep the data between you and that LLM. If you so choose to share this with a third party, that would be your choice. That is done, but it shouldn't be automatic. And one of the things that you got to think about is if you're using ChatGPT or Claude, what's happening to the data when you're sending these messages back and forth? What's happening to that data, right? Even though the policy may say we will not share data with another third party, that is not guaranteed, right? Another reason why is because you want to own your data, which is similar to privacy, but this is a little different. The data that you produce, the data that you're consuming, you want to own that data. Perhaps you're using something which is proprietary. This is something that you cannot share, right? That's something that you want to keep within your machine. Next, ability to customize. So if you're dealing with something where, say you're asking a question about a very touchy topic, such as politics, you want to get an unfiltered response. And many times, some of these LLMs nowadays are being conditioned, they're being modified so it will not respond to a certain topic. And if you have it local, then you can customize, you can fine tune, you can remove safeguards if you so choose to do so. Next, cost. I think that if you're running this locally, one of the advantages is that you get to run this as many times as you want. You don't have to think about credits. You don't have to think about, running out of money. You get to communicate with this and you can use this as you will. So this is a really great way to minimize cost. Now, what alternatives did I consider here? So again, Llama.cpp is just one LLM server out of many. I considered actually 5 of them. So yes, I did in fact end up going with Llama.cpp, but I also considered Ollama. And Ollama is really great. I actually liked Ollama a lot. However, one of the challenges of Ollama is that it appeared to be kind of like a black box because behind the scenes it would do things and you weren't able to see. Technically you can see it, yes. However, there's a layer of abstraction between you and it, which could be good. Some people don't want to see what's happening behind the scenes, but I do, right? And Olama hid that from me. So for example, when it came to downloading files, it would download to a certain folder, it would split the files into pieces. I want to have just one gguf file, right? I don't want to have many. um, yeah, so that's just one of the things. But if I were not using Llama.cpp, I would definitely use Ollama as my next best choice. Another option that I considered is an LLM server called Llama Edge, and this is really great. I really like the ambition that this project has. However, one of the challenges that I faced is I wanted to use a certain I wanted to use a certain parameter when starting up the LLM server, which was max tokens. However, I was not able to use it. So what I did is I went to GitHub, I created an issue. This is a couple weeks ago. And unfortunately, that issue has not been fixed. It's still there. So I do think Llama's Edge is actually it's promising. However, it's not fully baked. So I also considered VLLMs and SLang. So these are really great options. However, one of the challenges is that it takes just so much time to prepare the dependencies. I got stuck in dependency purgatory, right? So I'm not saying that it won't work. I do think it can work, yes. However, the amount of time that's going to take to get it up and running, the amount of issues that you have to work through to get it working, and then when you do have it working, the RAM that is consuming is extremely large because it's loading PyTorch, it's loading Pandas, it's just loading so many things in the Python runtime environment that it's not practical for production. So again, when I use these tools, I'm thinking about production, right? I'm thinking about what can I run in a production environment? Like what can I run on my own machine? Okay, so let's go to download an actual model, right? So now that we have the big picture, let's look at an actual model. So what I did is I went to Hugging Face and I looked for a lightweight model, and I found a really great one. This one is called Quen. I'm going to post this here. So Quen is a good model because it's pretty performant and it has various options, right? So as you see here, there are many versions of Quen. The one that I ended up going with was this particular version. Let me post it here. So I ended up going with Quen 1.5, 0.5B. So let me kind of like, touch base and let you know what's going on here. So 1.5 is a version. 0.5B is telling us that this is 500 million parameters. Chat is telling us that this LLM has been configured for chatting. Again, this is not a text to speech. This is not a text to image. This is just for chatting, right? So that's what this means. And then the format is GGUF. So GGUF is a newer format. It's replacing the older GGML format. And then also, I think before that, there's like a binary format like .bin. So GGUF is actually what Llama.cpp needs. I don't think you can run Llama.cpp with any other formats. So when you want to download this, you come to Files and Versions, and then here, scroll down, you'll actually see that you have many different kinds. Um, what happens here is that these versions of the 1.5 500 million parameters, the different quantized versions. And I chose the smallest one because this is definitely good enough to showcase the power that you'll have at your fingertips. And this is only 298 megabytes. So I actually downloaded this file already. I'm not going to download this again. Let me show you what this looks like. So I downloaded Quen here to my ML models folder, and here it is. Again, very, very small. So once you have that, go back to this. In fact, I'm going to keep this here. So once you have your model, the next step is to spin up your own LLM Llama.cpp server. And for this, I'm using Docker. So why Docker? I chose Docker because it removed a lot of the overhead. It was just a lot simpler. I didn't have to worry about installing requirements. And I actually have installed, I did install Llama.cpp without Docker, and it worked really well. However, I think for the sake of this demonstration, for the sake of getting you guys started, I highly recommend Docker because, again, the overhead is just so much smaller. And let me kind of like tell you what's happening here. So here again, this is Docker, and we are mounting a folder. So if you guys recalled, I have my Quen model downloaded here in my HTML models folder. So we are mounting that folder, and that allows us to access our Quen model within our container in a folder called models. And then here we are opening up port 8000 in my container to the outside host of 8000. And then all this is just, these are just arguments for the LLM server. Here, this is actually the path to the model that we're using, which is Quen. And you'll notice that here we're referring to this as /models. And then here, we're simply telling the server that, hey, we want the server to run on port 8000 inside the container. And if you guys remember, port 8000 maps to port 8000 outside the container. And then this is simply telling it that, we're using localhost. And here we have an API key. So when we're communicating with our large language model, we have to remember that we do have an API key, right? That's important. So now that we have this, we can spin this up. I'm going to go back to my terminal and enter that argument. Alrighty, so it looks like we have, okay, I see what's happening here. Let me, okay, so what happened is I actually have this already running in another window. So I just closed that one. So let's spin this up again. All right, here you go. So as you see, we now are able to communicate with our LLM via HTTP at port 8000. So let's take a look at communicating with this via our browser. So what I really love about Llama.cpp is that it has built in a GUI that you can access. And this is a big deal because this makes it so much easier. With other LLM servers, they didn't have this built in. This is something that you would have to do by yourself. You'd have to, find a tool. And there are tools that you can use, which is great. But again, I want to minimize the effort when it comes to interacting with these LLMs. Again, we want this to work out of the box. So what I want to do is I'm going to go to this particular resource in my browser. All right, perfect. So as you see here, we have access to a UI, and I can type and I can say something like hello, and it will respond to us. Now, one thing that I will note is that this worked, but I had to set my API key. So for you guys, when you spin this up initially, you're gonna have to come here and then type your API key. In our case, I use Apple as API key, but whatever you guys choose, you want to use that. All right, now um, I'm going to modify the prompt that's being used. So I'm going to go to setting and okay, so I already have it here actually. So I have you are a helpful or you are a coding. No, this is backwards. So I should put you are a helpful coding assistant. All right, good. So what does that mean? So this means that whenever I'm communicating with my large language model, it's going to be responding and it's going to be doing so from the role or from the context as if it is whatever you tell it here, right? So this is a persona your LLM will take on. All right, so I'm going to pass it a coding question and let's see what it gives us back. So it should give us back something meaningful. All right, so I'm asking it, how do I check if a Python object is an instance of a class? All right, so it says you can check if a Python object is an instance of a class by using the isInstance method. And here's an example. Awesome. So it even provides an example. So it has my object is equal to 1 to 3. Then it has isInstance, my object, and my class. And then it says true. All right. I want to show you guys something here. So what's important to mention, this is for the developers out there. So if I go to network and then I ask a question or I do a query, so I can say hello. All right. So I just typed a message. I said hello. And then this response is, how can I check if a Python function is called? Okay. So this response is kind of irrelevant. Again, it's not perfect. It's only, half a billion parameters. But what I wanted to show you guys here is that if you look here, you'll actually be able to see what's happening behind the scenes, right? So you'll see that your browser is querying this particular endpoint. And if you click on it, you see that it's sending this a payload. And this payload contains messages, right? And here, this actually keeps a history of your communication with the large language model. So you'll notice here it has the role, which was you are a helpful coding assistant. Then I typed hello. And then after that, it said, hello, how may I assist you? And then after that, I asked, how do I check if a Python object is an instance of a class? And then it had passed that whole response. So yeah, what's happening here, guys, is that it's actually keeping track of our conversation and it's storing that in local storage. So whenever you're using this UI and you're communicating, it's storing all of your messages in local storage. And then when you do a query, it's actually sending not just the query itself. So if I pass something like foobar, it's sending the query itself and it's sending all the other queries that you've sent. The reason why it's doing that is because it wants to keep a track of the context. So that way, the response that the LLM provides is going to be very relevant to your entire conversation thread. So that's something that I wanted to show you. What's cool about this is that this is actually related to my next point, which is communicating with the large language model via command line. So if you guys recalled, you saw how the browser was simply doing a call to a particular endpoint. So what I'm going to do is I'm going to bypass the UI and simply pass my query directly to the LLM via HTTP. So here I have a query that I've actually I just copied and pasted this. I had this in my other page. And what's happening here, it's doing a curl request. And here we have my model, which is, it's in my models folder. And we're referencing the Quen model in particular. And then here we have system. And then here we're telling the system that you are a coding assistant. And then as a user, my query is, how do I check if a Python object is an instance of a class? And then when we do this, we would expect it to give us a response. So let's see what it looks like. I'm going to come back to my terminal, clear that, and then we'll see what this response is. Alrighty, so wow, so it said a lot. So as you see here, we are able to directly communicate with our LLM. And the reason why this is important is because if you wanted to create your own application, if you wanted to use another application to interact with the large language model, you can. You're not restricted to this, right? You don't have to use this per se. You can use anything that can communicate via HTTP. Now, one thing that I will say is that this is really not readable. Like it's not human readable, right? This is really just one large chunk of text, and that's why really you would want to have something that would kind of like parse this out and then format this so it would be properly rendered and be easy to see. But again, this is just really a proof of concept that if you wanted to communicate directly to your large language model, you can do so without any issue. All right, so next we're going to communicate with this via Python. And let me clear this. So I'm going to write a Python function here, do nanomain.py. I need to check out my environment. So I have Conda on my machine here. So I'm going to do Conda activate ML. And you may ask why Conda? So Conda is what I use to manage my Python virtual environments. And Conda works extremely well for AI and machine learning applications because it's really built for scientific purposes, right? It has pandas built in, and it does a really great job of managing those dependencies. What I did here, what you did not see is that I did pip install OpenAI. So this is already installed. And when I have access to this library, I can actually create a Python program that is able to communicate to my LLM. And that's exactly what I'm going to do now. So let's see, I'll do from OpenAI, import OpenAI, and then I'm going to start a client. So client's equal to OpenAI. And then I'm going to have a completion object. So I'll do completion is equal to the client dot chat dot completions dot create. And the model that we have is the same one from before. So I'm just going to copy and paste that one over. And then messages. So I'm going to copy and paste over the messages because we have a lot of messages. It's a lot easier this way. All right. Messages. Perfect. So I should have everything. I don't believe that there are syntax issues. If there are, we will fix them and come back. All right. So once we have that, we want to print the response. I'm going to do print completion dot choices, and we're picking the first choice, so the first response that we have back, and then we'll look at the content. Okay, so this should work. I'll do Python main.py. Okay. Okay. So I see what's happening here. Okay, so it's telling me that I think right now it's actually reaching out to OpenAI, OpenAI.com, and I don't want it to. I want it to reach out to my local LLM. So what I forgot to do is I need to pass two, I need to export two environment variables. The first one is for my API key, which is Apple. So I'm going to export Apple. And then the next one is for my base URL. So this is going to tell OpenAI, at least our local library, that hey, instead of reaching out to OpenAI.com, we're going to be reaching out to this base URL, which is essentially the same one as my LLM. So now it should work. Let's give this a try. All right, awesome, it worked. So here, so what's interesting is that this response that we have is different from the one that we had before. And there's a reason why. The reason why this is different is because we chose different parameters like temperature. It's kind of like randomness or determine how deterministic your response is. And I think this one I did not set the temperature, but for the other one that I think I had a temperature of like 0.03 or something. But yeah, so my query was, how can I check the instance, right? And then it gives an example, which is really nice. It says we have an example class. Here you have X, Y, and then it says, okay, I'm looking to see if this is actually accurate. I'm curious if it gave us something that is accurate. So it says print example. This will output example as expected. Okay. Okay, interesting. So it does have code, which is great. Now, sometimes when you're communicating with an LLM and you're dealing with an LLM which doesn't have that many parameters, especially when it's heavily quantized, you'll have something which may not be as accurate. So I think the quantization for this is Q2. The higher the level, the more accurate it is. But on the flip side, the bigger it is. So let me show you something real fast. All right, zoom out. So hopefully you guys can see this. So here you have Q2, Q3, Q4, Q5, Q5, Q6, Q8. So here we have 2-bit quantization. So Q2, I believe, is for 2-bit quantization and so forth. And then Q8 is for 8-bit. And the higher it is, the more accurate. So we downloaded the one which is 298 megabytes, which does work. However, one of the disadvantages is that when you communicate with it, it will give you a response, but it may not be as accurate, right? Now in the machine learning world, we call this hallucination, where it will give you a response. It looks accurate, right? It's speaking confidently, but technically it's off, right? So that's something that you want to take in consideration. All right. So next, I want to kind of go over some ways of optimizing. So when it comes to optimizations, there are a few things that I do. The first one that I do is I look at max tokens. So max tokens is a parameter that you can pass when you're doing a query to your LLM, and you can actually limit the response from your LLM. What's important to note is that let's say your response would have been like 1,000 tokens. If you put 200 tokens, it would stop like mid response. It will just like give you 200 and stop. It's going to be an incomplete response. Now, one of the questions you may ask is, why would I want to do that, right? Why would I want to limit my tokens? The reason why is because, say you're passing a question or you're asking a question, which is a yes no question, right? So you're only supposed to get a yes or no. Sometimes when you query your LLM, it may want to write like a whole paragraph, but all you want is a yes or no. And what happens is, if you limit your max tokens, you're actually going to limit your response time as well. So instead of taking longer to prepare a response, which might be like 1,000 tokens or 3,000 tokens, right? It's going to either give you what you want, or if it gives you something else, at least it's going to be a lot faster. So this is something that I use. This is one of my optimization tricks. And in fact, let me show you how this works. So I'm going to give you guys an example. Let me go back to uh, go back to my UI here, and I will go to my settings. I'm going to go to advanced, and I'll put my custom Jason. So I'm going to do max tokens. Instead of doing 200, I'm going to do something like 2, which is extremely small. And then I'm going to ask a question that should be more than 2 tokens. So explain why water is wet. Not really a question. Let's see. All right, there you go. So as you saw, because my max tokens is restricted to 2, we just have 2 words, right? And that's it. So it gave us an answer and it's incomplete. But again, if you wanted to get a yes or no answer, like let's say I ask, is it hot? Notice that it said you can. So it's not a yes or no response, right? And even if I said, is it hot? Yes, respond with a yes or no. Respond with a, whoops, with a yes or no. Okay. So it says yes, which is good. So that's great. But again, sometimes it would give you a full paragraph and we don't want that. All right, cool. So another way of optimizing, let me go back to my notes here, is so this is again, this is something that I've kind of played around with and this worked really well for me. So when it comes to running your LLM or interacting with your LLM, I found that using these parameters have just worked and I kind of just like tweak them. So temperature again is analogous to like how deterministic it is, right? So if you wanted to give something different when you submit your response, the higher the temperature, the more I suppose that would vary, right? The less deterministic that would be. And then another thing that works really well is threads. So let's say that you want to get your response, but you want to get it back faster. Then you would increase your threads. Now here's a caveat, right? There's a limit. So if you put your threads to something like, like 16,000, at that point, it's not really going to make a difference, right? It's not. In fact, depending on your resources, maybe it's going to crash your machine. I don't know. I've never tried 16,000, but my point is, if you're doing a query and it's going to be something that might be, a little bit more in debt, like it's gonna require more resources, then increase your threads. So I've seen people use threads that's like 4. For me, I always use 16. I just use 16, and that's worked pretty well. So I would say when you're working with your LLM and you are querying it, I recommend using these args to get the best responses and the best results. So one of the questions that you would ask is, okay, where exactly would you specify this? So I'm going to go back to our GUI and I'll go to settings, go to general, and then here you see you can modify the temperature, top K, top P. If you scroll down here, you have more options of things that you can modify. Oh, so it does have max tokens. Great. You'll notice that with max tokens, that what I put here overrided the max tokens that they had here in general. Right. So that's what you would do in the GUI. And then if you wanted to do this via query, you would, let me show you an example. I think that would actually help you guys out a lot. So something like this. Do you see how you have messages and you model and so forth? So pretty much, if you wanted to do max tokens, you would come here. You write, something like max tokens, and then you put your whatever you want. So again, this is where you pass those parameters, and then once you have it, you just hit enter, and then it will give you your response. So yeah, that's it. That's pretty much what I wanted to show you guys. So from a high level, you guys now know, the benefits of, why you would want to run your own LLM locally, right? You know why, and then you know why you would want to use Llama.cpp instead of like other alternatives. Again, the next best option is Ollama. In fact, I think the next time I show you guys something, I might want to use Ollama because it's pretty good. And now you guys know exactly where to go if you want to download your LLM. Hugging Face is like the place. It is the place for models, right? If you want to get models, They have so many. They have models for every single thing that you want, pretty much, and it's free. Um, then, when it comes to setting up your Llama.cpp, you want to use Docker, and you want to use this particular command. And here's an example of doing command line. You can access via browser command line Python, and that's it. So hopefully you guys found this helpful. And if so, yeah, let me know in the comments. Let me know how this works for you. I'm really curious. Until next time, take care.